Hello students, I am Sonali Kelkar and today we are going to do the revision of the chapter Light. The first question, okay, now if a light ray IM is incident on the surface AB as shown, identify the correct emergent ray. As you can see over here, there is a glass slab and there is an incident ray I which is incidenting at a particular angle. Now this line is a normal. Okay, this normal, it makes a 90-degree angle with the surface. Now when a light passes from a rarer medium to the denser medium, as you can see in this picture, the first is air and the second is glass. So glass is a denser medium as compared to the rarer medium. Over here I can see there is a bending of light. We know that light bends towards the normal. This is my normal, light is bending towards the normal, right? And this is a ray, this is the refracted ray which is going ahead, and over here at this point there is again a bending of a ray when the light moves from the denser medium, that is glass, to the rarer medium, that is air. So at 2 points we can see the refraction, right? Whenever the light is traveling from rarer to denser and denser to rarer, in these case we can see there is a refraction of light taking place, right? And this light is bending away from the normal, as you can see over here. And we know that if I just extend the incident ray, this should be the original path. This is the original path of incident ray, and we can see there is a perpendicular shift of the ray from its original path, right? And this perpendicular shift is known as the lateral displacement. The perpendicular distance between the original path of the incident ray and the emergent ray coming out of the glass slab is called the lateral displacement of the emergent ray. Okay, so out of this R, Q and P, I need to see which ray is parallel to this IS ray, right? So Q is parallel to IS ray, that is the incident ray. So that's why the Q is the right answer for this question. Okay, next, the refractive indices of the four media A, B, C, D are given in the following table. Now let's see the medium A, B, C, D, and the refractive index of A is 1.33, B is 1.50, C is 1.52, and the D is 2.40. So whenever we have to compare the refractive index, we need to take two mediums, right? We need to take two mediums. Now the question asked over here is, if light travels from one medium to another medium, okay, so we are considering two mediums here, in which case the change in the speed will be minimum, and in which case the change of the speed will be maximum. Okay, so when there is a change in the speed, there will be a change in the speed when a light moves from the rarer medium to the denser medium, or from the denser to the rarer medium, right? From the denser to rarer medium. First we have to see the minimum change in the speed. Okay, so minimum change in the speed means there should be a minimum difference between the refractive index of the two media, because what is the refractive index is telling me? Refractive index is telling me that light, when enters into a particular medium, its speeds gets lesser as compared to the light travels in air. So there is a change in the speed of the light. Okay, more the refractive index, less is the speed of light in that medium. So let's see this question. First I have to find out the minimum change in the speed. So this will show if I take the two medium having the minimum difference in their refractive index. So as I can see here, 1.05 and 1.52, 1.50 and 1.52. So because the difference is coming 1.52 minus 1.50, so difference is coming only 0.02. So there will be a minimum change in the speed between the two medium B and C. Okay, between the two medium B and C. So my first answer is B and C. And when there will be a maximum change, so we have to look for the two medium which are having the maximum difference in their refractive index. So which is the least which is the medium which has the least refractive index over here? Medium A has the least refractive index, and medium D has the maximum refractive index, right? So the second answer will be medium A and medium D. When light travels between medium A and medium D, it is going to deviate maximum, it is going to bend maximum, because there is a large difference in the refractive index. That means the speed is decreasing very fast, and there is more decrease in speed, so there will be a more bending of light. Let's see the answer over here. Maximum change of light moves when it moves from 1.33 to 2.40, and in the first case when it moves from 1.50 to 1.52, that is from the medium B to C, and the second is A to B. Next question, how should a ray of light be incident on a rectangular glass slab so that it comes out from the opposite side of the glass slab without being displaced? So there is only one condition. If this is a glass slab and if I make a incident ray, okay, this is the incident ray which is overlapping my normal and my incident ray, they are overlapping with each other. It means the angle between the normal and incidence is 0. So angle of incidence is 0. Angle of incidence is equals to 0. So in this case the light will just go out from the slab without displacing it. Okay, so here we can say now along the normal to the surface at an incident angle I is equals to 0. Next question, a girl was playing with a thin beam of light from her laser torch by directing it from different directions on a convex lens held vertically. So she is holding a convex lens vertically and she is playing with the thin beam of light with her laser torch, and she was surprised to see that in a particular direction the beam of light continues to move along the same direction after passing through the lens. So state the reason for this observation. Okay, so at which point do you think that a light passes through the lens directly? There is no displacement. That is from the optical center. It is very simple. The question is quite big, but the answer is very simple. When she is making light to pass through the optical center of the lens, that time she won't find any change in the direction of the ray. That time she won't find any refraction of light. The light will go as it is. Okay. The ray of light passing through the optical center of the convex lens will continue to move along the same direction after refracting through the lens. Now redraw the given diagram and show the path of the refracted ray. Now as you can see here, this is a biconvex mirror, or we can say simply the convex mirror, right? And according to rule, we know that when a light passes through the focus, after refraction, it becomes parallel to the principal axis. Simple. So here is the picture for this answer. Number 6, children. The refractive index of diamond is 2.42. What is the meaning of this statement in relation to the speed of light? Okay, this is a very important question. It has been asked many a times in board exam. What do you understand by the refractive index of a diamond 2.42, or it can come 2.41, that doesn't matter, but what do you understand by this? Diffractive index of diamond is 2.42. Comment on this statement. It means that the light which travels in the diamond having a refractive index of 2.42, the speed of the light in diamond is 1 upon 2.42 times the speed of the light in air. Let's find it out how we can do. Let's first find it out, the relationship between the refractive index and the speed of the light. See children, there is a very simple relationship. If the refractive index is more, if refractive index of any medium is more, then the speed of the light in that medium, Vm, speed of the light in that medium will be less. How? Because they are inversely proportional to each other. Let's find it out how they are inversely proportional to each other. First of all, we will write the formula of refractive index, which is represented by the nu C upon Vm. C is the speed of the light in vacuum, Vm the speed of the light in medium, and nu stands for the refractive index, right? As you can see over here, this is a refractive index and this is the velocity of the medium. So nu is equals to, if I take C as a constant, Vm, right? So we can see they are inversely proportional to each other. If I just interchange the position, if I write velocity of light in a medium is equals to 1 upon refractive index, right? In this case, I can see that if there is increase in refractive index, velocity will decrease, and vice versa. I can see the relationship very clearly. If the refractive index is more, the velocity will be less. If the velocity is more, refractive index will be less. So in this case, I just have to substitute the value. That is, V is equals to speed of the light in diamond. Okay, speed of the light in diamond, D-I-A-M-O-N-D. Speed of the light in diamond is equals to 1 upon 2.42. It means when a light enters in a diamond, its speed will get reduced by 2.42 times. It will get reduced by 2.42 times, or by 1 upon 2.42 times. It will get reduced, it will get lesser by 1 upon 24 times. Now let's take the next question. A ray of a light incident obliquely on the face of a rectangular glass slab placed in air emerges from the opposite side or the opposite face parallel to the incident ray. Just now we did about this. There is a displacement of the ray. Okay, the displacement of the incident ray from its original position to the other position, and this is a lateral displacement. Lateral means sidewise it is moving. Okay, the incident ray which is supposed to take this path or the original path, it has moved sidewise, and this sidewise or perpendicular displacement is known as lateral displacement. Okay, state two factors in which the lateral displacement of the emergent ray depends. So there are certain factors, that is angle of incidence, and it is directly proportional to angle of incidence. It means if I increase the angle of incidence, incidence, then my lateral displacement, okay, displacement will also increase. Now thickness of the slab, if I increase the thickness, okay, thickness, if I increase the thickness of the slab, if I increase the thickness of the slab, the lateral displacement will also increase. I'll just write the short form of lateral displacement, LND. Refractive index, if I increase the refractive index, my lateral displacement will also increase. So this is how it is related. These all three things are related. Okay. With the help of a ray diagram, explain why a convex mirror is preferred for a rear view mirror in a motor car. What is the usefulness of rear view mirror? Why do we keep rear view mirror? Why do we use rear view mirror? Because I want to see the vehicles which are coming from the back side, right? In a car, I use a rear view because here I want to see which all vehicles are coming from the back. Okay, so to know which all vehicles are coming from the back, I want to see all these vehicles. First of all, I want to see all these vehicles in an erect condition, erect position, upright position, right? And I want to see them diminished also. Okay, why I want to see them diminished? I don't want to see enlarged images of these, because I want to cover maximum area. I want to cover maximum area. So for that, convex mirror is the best. Now let's draw a diagram of a convex mirror. Okay, now this is a convex mirror, fine, and the rays which are coming, you can see, show the rays like this which are coming. Okay, they will reflect it back, they will reflect back, these rays are reflecting back, but if I extend it backwards, these rays are going to meet at focus. When they are reflecting back, that time they are covering a large area. That is why I need a convex mirror where I can get a virtual images, erect and diminish, DEV, diminished images, right? Virtual, erect and diminished images, as well as I want to cover the maximum area, right? So this is the answer for this question. It always forms a virtual, erect and diminished images. The field of view increases while using a convex mirror. Let's do question number 9. Draw the following diagram in your answer book and show the formation of the image of the object AB with the help of a suitable rays, right? Now as we can see in this diagram over here, this is my concave mirror, and I have kept an object at A. There is an object at the object is between C and F, between focus and the center of curvature. There is an object. Now we have to follow the rules of the ray diagram. The first rule is when a light is parallel, when a ray is parallel to the principal axis, after reflection it passes through the focus. Now the next rule which I am going to follow, when the ray of light passes through the focus, after reflection it becomes parallel to the principal axis, right? So I can see over here, when a object is placed between C and F, the image is formed beyond C and F and this image is enlarged. Here is a correct ray diagram with the help of a ruler, and the ray diagram, as you can see over here, when an object is placed between center of curvature and focus, the image is formed beyond C, because these ray of lights, they are actually meeting after reflection. So I can see the image formed is a real images are also always inverted images. So real images and inverted images goes hand in hand together. Okay, and as we can see in this diagram, it has been drawn very clearly. Next question, which kind of mirrors are used in the headlights of motor car and why? In the headlights of motor car, what happens, I want my light to fall or to cover the maximum distance, and the light should be bright enough. To solve my purpose, I need to keep my bulb at focus. If this is a concave mirror and if I keep my bulb at focus, I know that the rays after reflecting, okay, these all rays, if I keep a bulb over here, the rays which are parallel to the principal axis, okay, after reflection, these rays passes through the focus and I will be getting all parallel rays. Okay, we know that concave mirror is a converging mirror, and when I keep the bulb at focus, I will find that the parallel rays are coming, and these all parallel rays are really powerful rays. It will cover the maximum distance. I can see the object at I can see the distant object also because of this powerful rays, and because of that I would prefer concave mirror, and I would prefer the bulb to be kept at focus. Let's read the answer. A concave mirror is used in the headlight of a car because concave mirror is a converging mirror. This is advantage. Then in headlights, the bulb is kept at the focus of the mirror, due to which the rays emerging from the bulb after reflection forms from the mirror becomes parallel to the principal axis, right? So hence we get the powerful beam of light which can go to the farther distance. Now redraw the diagram given below in your answer book and show the direction of the light ray after refraction from the lens. As we can see here, this is a concave lens. This is a concave lens. Concave lens are diverging lens. These lenses are diverging lens. So a ray of light, this is a ray of light, passes through the concave lens. Okay, now if I just extend it, it is going through the focus, but after refraction it should go parallel to the principal axis. So this ray becomes parallel to the principal axis, right? Here is a diagram which you can draw it in your copy. Question number 12. The refractive index of water is 1.33 and the speed of the light in air is 3.3 into 10 to the power 8 meter per second. Calculate the speed of the light in water. For this, we are going to use the formula of refractive index, that is nu is equals to c. Small c is the speed of the light in air or vacuum divided by the speed of the light in medium, right? So out of this, what do we know? We know the refractive index of water. So I am going to keep 1.33 over here. Speed of the light is 3 into 10 to the power 8 divided by speed of the light in medium. So medium is water. So Vm we have to find out. To find out Vm, I am going to keep the Vm here. So Vm will come over here. There will be a shifting of the values of refractive index. Refractive index will take the place of Vm, that is velocity of light in a medium, and once we solve this we will get the answer, that is 2.5 into 10 to the power 8. So 3 divided by 1.33, so that will be 2.5 into 10 to the power 8 meter per second. So this will be the speed of the light in water. Next question. The refractive index of glass is 1.50. So they have given the refractive index of glass. So I'll just write nu G, refractive index of glass, which is 1.50. Speed of the light, again c, small c, represented by small c, 3 into 10 to the power 8 meter per second. Calculate the speed of light in glass. So we have to calculate the speed of light in glass. So Vm we have to calculate. Okay, so let's find out. Okay, so we have to find out V, speed of light in glass, speed of light in medium is equals to C upon nu G. So Vm, C is 3 into 10 to the power 8, and what is refractive index of glass? That is 1.50. Okay, so if I solve this, I'll be getting 300 divided by 150 into 10 to the power 8, right? So this will cut. 30 divided by 15 is 2. So we are getting 2 into 10 to the power 8 meter per second, which is the speed of the light. This is the speed of the light in glass. Let's do the next question. What is the nature of the image formed by the concave mirror if the magnification produced by the mirror is +3? So this is a magnification problem. The plus sign always stands for virtual image, and we know that virtual image are always erect or upright. Whichever word you want to use, you can use. So plus sign stands for virtual and erect image, and 3, because this 3 is more than 1, so the image is enlarged. Okay, the size of the image is more than the size of the object. Okay, because it is 3. When the magnification is more than 1, then the size of the image is always greater than the size of the object. Okay, so you can read the answer over here. Positive sign of magnification indicates the image is virtually erect, and 3 indicates that it is enlarged because it is more than 1. Between which 2 points of a concave mirror should an object be placed to obtain a magnification of -3? This is -3. So where should I keep the object in a concave mirror? In a concave mirror, so that I get the magnification of -3. Now first we will understand what this -3 stands for. Minus stands for the image should be real, and when it is real it has to be inverted. So I should get a real and inverted image, and my image should be enlarged. Why enlarged? Because this 3 is more than 1. It means the size of the image is more than the size of an object. Okay, so in this case I should get a real inverted image and enlarged image, and we know that if I keep the object between F and C, okay, in the last slide we have seen that when I keep the object between center of curvature and the focus, if the object is placed between center of the curvature and focus, I'll get the image beyond C, and the image is enlarged. It is almost double the size of the object. So this is the answer for this question. Next, the refractive index of carbon disulfide is 1.36. Okay, what is the meaning of this statement? Just now we did regarding the diamond. Refractive index of diamond is 2.62, something like that we did. So in this case, same thing, refractive index of carbon disulfide is 1.63. That means, it means the light, the velocity of the light, or the speed of the light in carbon disulfide is 1 upon 1/6 time to the velocity of light in air. In air. It means when a light enters from air to the carbon disulfide, okay, to the carbon disulfide, then its velocity gets decreases. And how much it decreases? It decreases by 1 upon 1.63 times. Okay. Next question. The outer surface of a hollow sphere of aluminium of radius 50 centimeter is to be used as a mirror. So radius is 50 centimeter. Let's draw a surface of aluminium, right? And this is the radius is 50 centimeter. Okay, that means the center, this center is 50 centimeter away from this surface, right? That means the center of curvature is 50 centimeter. What will be the focal length? We know that focal length, that means what is focal length? It is a distance between the focus and the pole. Focal length is a distance between the focus and the pole. Okay, so this focal length is half of the center of or radius of curvature. Okay, the distance between the P and the pole and the center of curvature is known as radius of curvature, and distance between the P and F is known as focal length, and this distance is always half of the radius of curvature. So if the center of curvature is 50 centimeter, then radius of curvature will be 50 divided by 2, that is 25 centimeter. Which type of spherical mirror will it provide? It will provide a convex mirror, because we have taken the outer surface of the hollow sphere, so it will going to provide me the convex mirror. Okay. Let's take the next question. Between which two points related to the concave mirror should an object be placed to obtain on a screen an image twice the size of the object? Now, when I read the statement, I have noticed that the mirror is concave mirror, right? It is a concave mirror. And they have asked that where should I keep an object? This is my focus. This is my center of curvature. Where should I keep the object to obtain on a screen? Object with like the image I am getting, it is to be obtained on a screen. Which type of images we can obtain on the screen? Real images, right? The moment I read the word obtain on a screen, that means it has struck to me it is real. When it is real, it has to be inverted, right? It has to be inverted, and the image is inverted, real, and twice the size of the object. It means it has to be enlarged. So we know that if I keep my object between center of the curvature and focus, I'll be getting image beyond C, and which is real, inverted, and enlarged. Okay, so this is very simple question. Let's take the next question. The speed of the light in a transparent medium, speed of the light in a transparent medium is 0.6 times that of the speed in vacuum. Okay, let's take the speed in vacuum. Okay, it is 1, and speed of the light 0.6 times the speed of the light in vacuum, so 0.6 into C. Okay, or we can just find out the value. What is the refractive index of the medium? So nu is equals to 1 upon 1.6 C, or if I solve this, I'll get the answer 1.67. So the refractive index is 1.67. Do we have any unit of refractive index? No, we cannot have the unit of refractive index, because if I see, it is the ratio of the same quantities. C is the speed of the light in air, and V is the speed of the light in any medium. So we are taking the ratio of the same quantity. When we take the ratio of the same quantity, the unit gets cancelled, and that is why we don't have any unit for refractive index. Next, explain with the help of a diagram why a pencil partially immersed in water appears to be bent at the water surface. So you have to draw a diagram, and then you have to show how the position of the pencil have shifted. Okay, it has, you can see the apparent position of the pencil. The pencil have shifted little up, and you can see that the original pencil is just below to what you are looking at, right? So to draw the diagram, it is very simple. First you have to draw a glass tumbler filled with water. Then you can draw a pencil over here. This is my original pencil, right? Then you have to bring two rays. Okay, you have to bring two rays like this, okay, and draw a normal. We know that when light enters from rarer medium, from air over here, rarer medium to the denser medium, that is water, it bends towards the normal. So it will bend towards the normal. This rays will bend towards the normal, right? It bend towards the normal, and what we are going to find out, that after bending they are going to meet somewhere over here. Okay, somewhere over here. Okay, so wherever these rays meet, over there we are going to see this pencil. Over there we are going to see the pencil. So this pencil is the image of the pencil that we are seeing. It is just above the original pencil, right? We can read out the answer from here. Light from the different points on the pencil immersed in water refracts and appears to come from a point above the original position, right? So you should know how to draw this diagram. Next question, define and show on a diagram the following terms relating to the concave mirror. First of all, aperture, and then the radius of curvature, right? Now what is the radius of curvature? The diameter of the reflecting surface of the mirror is known as aperture. I'll show with the help of an image over here. There is a mirror we have taken, and this whole diameter, the whole surface, okay, the whole reflecting surface, it is aperture. As you can see, it is aperture. This is an aperture. And what is a center of a radius of curvature? It is a distance between the pole and the center of the center of the sphere. Center of the sphere is also known as center of curvature. So distance, this complete distance is known as radius of curvature, right? So we have shown with the help of a diagram. Let's take next question. In an experiment with a rectangular glass slab, a student observed that a ray of light incident at an angle of 55 degree with the normal on one face of the slab, after refraction strike to the opposite face of the slab before emerging out into air, making an angle of 40 degree with the normal. So let's understand this step by step. So there is an experiment. In this experiment, we have taken a rectangular slab. The student have taken a rectangular slab. What he observed, that a ray of light incident at an angle of 55. That means the angle between the normal, this is my one normal, this is my second normal, right? The angle between the normal and the incident ray. So this is the incident ray, this is the incident ray. The angle I over here is 55 degree, right? And then when the light enters into the glass, then definitely it is entering into a denser medium, so it bends towards the normal. Okay, otherwise see, it is going straight. This light, the original path should be this, but it is not following the original path. It has bent towards the normal. then the angle between the normal, this is normal, then the angle between the normal and the refracted ray, this is a refracted ray. Okay, this one is a refracted ray. Angle between the refracted ray and the normal is 40 degree. This is 40 degree, right? And draw a label diagram to show the path of this ray. So I have to show the path of this ray. What value would you assign to the angle of refraction and the angle of emergence? Now if this, they are talking about the R2, this angle of refraction. So as I can see, R1 and R2, don't you think that these are the alternate angle? These are the alternate angle, and we know that alternate angles are always equal. So R1, which is 40, okay, which is 40, and R2, which will also be 40 degree. Okay, R1 and R2, R1 is equals to R2. If R1 is 40 degree, then R2 will also be 40 degree, because they are interior alternate angles, right? And what we have to find out, the angle of emergence. We know that angle of incidence is equals to angle of emergence. If angle of incidence is 55 degree, then angle of emergence will also be 55 degree. So this is the answer that you can read out later. Now let's do question number 23. It's a big question. At what distance should an object be placed from the convex lens of focal length 18 centimeter, right? So we should remember what is a convex lens and where is the primary focus of convex lens. The primary focus of convex lens is always on the right hand side over here. This is f2 and this is 2f2. Okay, my f2 is 18 centimeter, and because it is on this side, we should know the Cartesian, right? Just know the Cartesian. It is on the plus side, this is a negative side, right? So 18 is on the plus side. 18 obtained on to obtain an image at 24 centimeter. Okay, so what distance should an object be placed? So we should find out the object distance, that is, we should find out the u. And they have given focal length f is equals to 18 and it should be plus. And they have told that image is formed, that is v is formed at 24 centimeter. In case of convex mirror, the images are formed mostly on the right hand side, that is, the v should be plus. What will be the magnification produced in this case? We have to find out magnification, right? So to find out the magnification, I should know either the height of the image, height of an object, which is not given in the question. So I will take the another form of magnification, another formula of magnification, that is m is equals to v upon u. Okay, from this given I can find it that my u is not there. So I have to first find out the u. To find out the object distance, I need to use the formula of lens. What is the lens formula? Lens formula is 1 upon f is equals to 1 upon v minus 1 upon u. Okay, so I have to find out u with the help of this method. So if I find out 1 upon f is 18, 1 upon f is 18 is equals to 1 upon v, that is 1 upon 24 minus 1 upon u. So if I interchange the position, my 1 upon u will come here. I will have to make it a positive 1 upon u, and 1 upon 24. I have to bring 1 upon 18 over here. It will become minus 1 upon 18, right? If I find out the LCM of 24 and 18, I'll get 72, right? 24 3 are 72 and 18 4 are 72. Now I'm getting minus 1 upon 72. So my 1 upon u is equals to minus 1 upon 72. So therefore u will be minus 72, right? Now just substitute this value of u in magnification. M is equals to V upon U. V is 24. U is 72. It is minus. I'll put the minus sign here. It will become minus. It will become 24 1 r 24 24 3 72. So minus 1 upon 3. So minus shows that the image is real and image is erect. Okay, and 1 upon 3, of course 1 upon 3 is less than 1. 1 upon 3, okay, 1 upon 3 is it is less than 1. 1 is a magnification, so definitely the image is diminished. Here is the solution of this question. Next, the ray of light traveling in air enters obliquely into water. Okay, now the first medium is air, medium 1 is air, medium 2 is water. Does the light ray bend towards or away from the normal? From rarer medium to the denser medium, when a light travels from rarer medium to the denser medium, this is my normal, this light will bend towards the normal. Otherwise the ray of the original path of this light is this, but it is going to bend towards the normal. Okay, you have to draw the ray diagram for this, and this is the ray diagram. When a beam of a light passes from air into a substance X, okay, and if the angle of incidence is 72 degree and the angle of refraction is 40 degree, so they have given angle of incidence and angle of refraction. Calculate the refractive index of a substance X. So in this case, when the angle of incidence and the angle of refraction is given, so we have to use the formula sin I upon sin R, which is equals to the nu, that is refraction. For the given set of medium, the sin I upon sin R is always constant. Sin I upon sin R is always constant. It is constant for a given set of medium. For a given set of medium, the medium should be same, either air water or water glass or glass water, the medium should be same, right? Then they are constant. So let's substitute the value. Sin I is 72, so sin 72 degree, sin 72, sin 40 degree, right? So we have to find out the value of sin 72 and sin 40. So that is 0.951 and sin 40 is 0.642. This values will be given. It is given in the question itself, sin 72, sin 40. Okay, it is given over here, so you just have to substitute, and when you solve this, I am getting a refractive index is 1.48. okay. Question number 26, children. Now you have to be very careful when I will do these questions, 26, 27 and 28. These are the very fundamental type of question. If you know the fundamental concept, you can able to do this numericals, right? Let's start with the question number 26. The refractive index of water for light going from air to water. Now there are two medium. The first medium is air and the second medium is water. So whenever you write these type of numericals, you should be very careful how you are going to write. So we are writing refractive index, that is nu. The second medium is water and the first medium is air, right? So in this case we are going to write, we are going to take the second medium first, that is we are going to take the refractive index of water with respect to air, WA, or you can write 2 121, right? And when you write this, what do we mean by with respect to? With respect to means you have to put a division sign. That's it. That means W divided by air. Okay, that means W divided by air. Okay, with respect to, or it means upon, UPON, upon. Okay, that means refractive index of water upon A, refractive index of air. That's it. Okay, now the second condition is the refractive index of water with respect to air. They have given 1.33, so we should have written 1.33. Here I just want to say one thing. In these type of question, there can be a little change. They can also say that the question can be put in a different manner. That is, the refractive index of water with respect to air is 4/3. Okay, we can also write the refractive index of water with respect to air is 4/3. Okay, when you get this type of question, again you have to write refractive index of water with respect to air. First water, then air, and which is nothing but 4/3. Okay, so I am simultaneously doing two type of sums. Now, what will be the refractive index of light going from water to air? Initially, the light was going from air to water. Now, it is going from water to air. Now, which is the second medium over here? Second medium is air. Second medium is air. So, refractive index of air with respect to water you have to write. Okay. So, it is the reverse case. It is just a reverse case. So, what I am going to do is I am going to reverse this fraction. 1/33 can be written as 1/33 divided by 1. Okay. Now, because the two mediums are just get reversed, I can write that 1/1.33, right? I have just reversed this fraction. Over here, I am going to do the same thing. Refractive index of air with respect to water. That means air divided by water. Air divided by water, definitely it becomes just reverse. That is 3 divided by 4. Okay. So this is the answer. What is 3 divided by 4? What will be the answer for this is 0.75, right? And here also, when you solve, you are going to get the answer 0.75 approximately. So this is the answer of these type of question, where you will see that the two mediums are getting just reverse. Next question, 27. The speed of the light of a substance is x. Okay, so speed of the light of a substance is x. So speed of a light of a medium is 1.25 into 10 to the power 8 meter per second. And that of the air is 3 into 10 to the power 8 meter per second. So we have to find out the refractive index of this substance. So we know that refractive index of x, let's take x, is equals to the speed of the light in air divided by the speed of a light in medium. So it's very simple, 3 into 10 to the power 8 divided by 1.25 into 10 to the power 8. This thing will cut off. And what is 3 divided by 1.25? So we can just solve it. So 300 and 125, right? If I solve this 300 and 125, I'll be getting 560 divided by 5 2 are 10, 525. Then this will also go 512 divided by 5. Now what is 12 divided by 5? It is 2.4. So the refractive index of the medium X is 2.4. 4. Next question, the refractive index of glass with respect to air. So whenever you get these type of questions where the first medium is air, refractive index of glass, that is nu, refractive index of glass with respect to air, right? So in these type of questions you can also write nu g, that's it, because this is a absolute refractive index. Absolute refractive index, in case of absolute refractive index, whenever the first medium is air, in that case we say that the refractive index is an absolute refractive index, right? Wherever the first medium is air, okay, that type of refractive index can be set as absolute refractive index. Or when light is going from vacuum to another medium, then the value of refractive index is called the absolute refractive index, okay, and which is nothing but 3 upon 2, okay, which is nothing but 3 upon 2. And the refractive index of water with respect to air. Now refractive index of water with respect to air, we can also write NW, which is 4 upon 3, right? The respective index of glass with respect to water will be, now they have asked refractive index of glass, which is this, with respect to water, which is this, right? How I am going to write? Refractive index of glass, okay, with respect to water, glass with respect to water. Now as I told you, with respect to means division, that means G divided by N is equals to G divided by W, isn't it, right? Now what is G? What is the value of G? 3 upon 2. What is the value of W? 4 upon 3. Done. Now we have to do 3 upon 2. This 4 upon 3 will get reciprocate. It will become 3 upon 4, which will be 3 into 3 is 9 and 2 into 4 is 8. Now what is 9 divided by 8? Okay, what is 9 divided by 8? 9 divided by 8 is going to be 1.125. So this is the answer of this question. That is it. Okay, so this is how we are going to solve these type of numericals. Thank you so much and practice today's session.